Well, hello everyone. Today I'm gonna make a quick video about some interesting tools that I have found and they just now arrived. And I think they're worth taking a look. Now, the most basic one that I've ordered, which actually came in a packet that was, well, saying it was wrecked, it's a understatement. And it was this box, this clip, and the solder, and this USB-C to a USB-C cable. But it's a soldering iron, which it's about 20 bucks to get. And I actually ordered some tips for it, but they didn't actually arrive yet. But I've already tried it out just in case it was faulty or something. But no, it actually works. So it's this looking USB-C and barrel jack power. The front it has the connector for this. This right here, it's actually a grounding point. That's why they give you a grounding lead. Uh, this is a T100, I believe, tip. The others that I've ordered are T80, and that's why they also have these to make it compatible. And they have a tiny little stand, which, well, can't particularly say it's useful, but it's something, I guess. It's good that they at least gave you this thing in the packet, in the box. We have some soldering iron, which I've tested. Seems to be like 350-degree solder. It's basically your standard leaded solder from what I saw. The grounding tip, well, maybe I'll try later, maybe not. I don't know yet. But yeah, this is a USB power delivery smart soldering iron thing. It's just a cheap thing that I believe it's very good for beginners. I have a power delivery compatible power bank here. It's, I believe, the max output it's 9 volts, 2.5 amps. So no 100 watt or anything amazing, but it should work. And I've actually tried it and does work. Very slowly, but it does work. And as you can see here, it's gonna take a quick minute to heat up. Till then, we're gonna look at the other thing that I've bought for it, and it's a very cheap power brick. It's 24 volt, 5 amp. It got a barrel jack, and this is what I actually plan on using to heat this up and use. Because, alright, call me, skeptic, but I don't really think the internals are really rated for power delivery. Whatever watts they can handle. So, this is likely gonna be like a MOSFET in between, and that's it. It's basically just a resistive load, so it shouldn't be that dangerous. I mean, I don't really know the PD standard, but I assume it's complicated than just power in and resistor. Again, this power brick, it was like 10 bucks. Can't particularly recommend one of these because even though it has a grounding point in here, the actual plug that it came with, it's two-pronged only, so no earthing. which is slightly concerning, to be honest. But it's a soldering iron. It shouldn't really be that big of an issue, especially since it's one of these low wattage ones. So let me adjust the temp up to the 305 that 350 that we need, and 355, good enough, that we need for the actual solder to melt. And after we use the PD power bank, we're gonna actually switch to this one and see how well it heats up and everything. But yeah, it's the build quality, well, I'll be honest, it's not the best. It's just plastic. That's all it is. Just simple plastic. No, nothing fancy about it. The cable, it's actually pretty nice. It's a silicone cable, and it has a light in front, which can particularly say does much, but maybe it's gonna help in some weird particular situation. I guess it's worth being there. And on the side you can actually see PD 9 to 20 volts, DC 12 to 24, and the center is positive, which you can actually find different things that have the center negative, which usually ends up in you blowing it up if you're using a standard power supply for it. But yeah, this should be pretty fine. I wanna recommend this to beginners because you aren't supposed to do that, powerful kind of soldering that you need like a few 100 watts. This is like 100 watts at most, and this power supply that I got, it's 120 watts. So there's not that big of a risk of anything blowing up. I hope. I guess I'm gonna find out eventually. But yeah, as you can, as I'm trying here, you can see it's melting solder. The tip is a bit crunchy, let's say, from the last time that I tried using it. So I'll just get my this brass copper thing sponge that you're just gonna quickly do this, and it's supposed to clean the tip up. And now I should probably use some kind of what's it called, flux. But yeah, as you can see, it's melting solder even on this low power bank that can barely deliver like, I don't know, 20 watts. So it can be good on the run. I would actually recommend, if you're on the run, to get a more powerful power bank that can do at least like 50 watts. But let's see the menu, I guess, while we're at it. I hope the camera can actually record. But we have the sleeping temperature, the sleep time, the standby time, stepping, unit switch, which it's to switch from Celsius and Fahrenheit. We also have language display to flip it if it's on one side or the other. Here you can turn the LED on and off. Here is where you can compensate the tip if the... great, come on. Where you can compensate the tip to be plus or minus some amount of temperature. Gear, I still don't know what that does, and gear temp. This is factory reset, and yeah, the sleep temperature, it's when you let it down for a few minutes. and it's gonna go down to like, I don't know, you set of a certain temp. Like, alright, come on. Do you really need to go that fast into... Alright, let's see. To hold to basically OK, you just hold the B button. So here you can set the sleep temperature, which is gonna be, I'll set it to 200 degrees. And when you pick it back up, I will assume it has an accelerometer or something inside to detect when you pick up. The sleep time is basically how much time it's since you've put it down to enter the sleep. 2 minutes, it's fine for me. You can change it. The standby time, it's the time where it's actually gonna cool down fully. I have it at 5 minutes. I believe that's a good point, but again, everyone is gonna find their own timing and everything. The stepping is how many steps it takes to change this temperature, and unfortunately you can't OK in this one to go faster back, but yeah, this is a cheap and probably safer than other live mains soldering tools that you can find, because it's 24 volts, and even though it's pretty spicy, if you ask me, it's not as bad as 220 volts, for example. So yeah, I'll unplug it. I'll let it here and cool down, and after a bit I'll actually plug in the 24 volt supply, which should actually give it a pretty nice boost in performance, considering that was just you know, on a cheap power bank that I got for like 20 bucks. I believe that's what I paid for it. So till it cool down, I'll put this here, and till then let's talk about the next thing that I found, which it's these things, SMD grippers and test clips. That's apparently what they're called. I don't exactly know what their full name would be, but the idea of this, it's pretty simple. So you know the very small SMD chips. Actually, hold on, let me get a board. There we go. For these type of small chips, and these, I don't know if my camera will be able to record, but they have little wires, prongs. I don't know what they're called, but you use these to clip onto the pins of a certain IC. If my hands wouldn't shake all over the place. And now that you got it there, you could straight up take, for example, a oscilloscope probe and just hook it here. But this is kind of heavy. So what I would recommend you actually do, let me find one sec. There we go. You use these Arduino DuPont connectors, connecting wires, and you just put it like this, and now you can measure without having all of that weight on the actual clip that you're using to measure. This set of 10 costed me about 10 euros, 10 dollars, 10 euros, I don't know. To me, both currencies are the same, so just, you know, search search, I don't know, Amazon, AliExpress for these, and you should probably be able to find them under some name. So yeah, I just quickly wanted to show these off because I think they're really cool. Let me get all of these out of the way. Alright, let's try the power supply. Let's see if anything blows up. There we go, the power supply booted up. And as you can see, it's way faster heating up. And should actually be able to handle melting solder better now. And I forgot to actually... Don't be like me. Wait for it to cool down and then adjust the tip, but... You know, I'm gonna do a little bit of that. And now, we should be able to melt solder. Great. I'm a professional. I managed to burn myself with solder. Ah, but yeah, as you can probably see, it's good enough. Solder seems goodish. It's not particularly amazing, but you know, it's good to get started. So yeah, the soldering iron, it's good enough. I believe for a beginner. Great. Can I stop burning myself like an idiot? The soldering iron, I believe it's pretty good for beginners. It's not amazing. It's not anything to write, a whole article about. But it's gonna get the job done. It's, I believe the fact that it's on 24 volt, it's less likely to have any kind of shock hazard. So, I mean, there's still a burning hazard, as I figured out uh, 2 times so far, but that's for any soldering iron. And the grounding clip, well, let's just open it up while we're at it. It's something, I guess. Yeah. Alright. I'll let this cool down. Let's not burn the house down yet. Alright. So that's with the power supply. Alright. Another cool thing that I want to show you. It's these LCR tweezer things you can find. And I must say this right now. From what I've heard, they're not that great at being tweezers, but they're actually pretty great at being meters. So for about 30 bucks, I want to say, 30 euros, you can find one of these, which come in a pretty nice case, if you ask me. I would have loved to have like a indent or something, so I don't have to use my nails to get it out. But you power them on, and they're just basically an LCR meter in the form of a tweezer. I can't particularly say if the accuracy is that good as an LCR meter, and well, I doubt it. But what I do want to test out and want to compare with my multimeter actually, it's if they actually output a proper sine wave to test out the components that you're putting on. So let me dig out the multimeter. There we go. And if I put it in capacitance, which both of these should be able to do, I'm gonna start with capacitance because this is where it matters the most. So if I ground it, you can actually see it's just a I guess it wants to be a sawtooth wave or triangle wave. I don't know, one of two. But As you can see, it's come on. Let me change this to ACRMS. Come on. It's 6.5 millivolts. Uh, 0.6 volts basically. 0.65 volts. And it's outputting a sine wave, what, 256 kilohertz? From what I can see. So this is gonna change on any kind of multimeter. Everyone does their capacitance measurements differently, so you can't expect these exact results for any multimeter or anything. And well, when we get to resistance, it's just a purely DC voltage. And the spikes you're seeing are actually just common noise that I still need to figure out how to take out. There is something in my room that makes that noise and I still don't know what it is. But yeah. This is how multimeter do it. But if this should actually output a sine wave. And let's see. Let me put it down to 100 hertz, for example. Let's do an auto and see if... There we go. 101 hertz, apparently. It's gonna be a bit all over the place because of my command mode noise that again I still need to figure out how to take out. But as you can see, it actually does a proper sine wave, which means the measurements are gonna be more accurate than that of a multimeter. And the good thing is that you can actually switch the frequency, increase it and decrease it. Now it's at 1 kilohertz. If I press it again, it goes up to 10 kilohertz. And that's just gonna be your values that you're gonna use for capacitors. Now, I am no expert on LCR meters, but from how I remember it, the higher the capacitance that you expect to measure, the lower the frequency. So keep that in mind if you're gonna get one of these and wondering why your measurements are off. Higher capacitance, lower frequency. Now, it also has two values for the voltage. 0.6 volts, which is 581 millivolts here, considering the resistance of this. Yeah, sounds about right. But also 0.3 volts, which is actually for measuring in circuits, so diodes won't interfere with different circuits. They won't be interfering with the measurement, which it seems pretty close considering the slight resistance that this and the common mode noise and everything. So yeah, let's actually test it out on some components. And let me get this out of the way because we don't need it anymore. God damn it. Everything's falling apart. I guess it's low effort electronics for a reason, huh? Now, let me get some capacitors. Alright, here is my organizer full of capacitors, mostly, but I also have other stuff. Alright, let's first put it on 0.6 volts because that's pretty much the default. And let's go 100 hertz and let's measure this one. This is 100 microfarads. Let's see, what does it give? 92. Close enough, I guess. This one, it's 56, I think. I don't know, let's just measure it and see. 50, 560 nanofarads. Let's try an, what is this, an XY class capacitor? X class capacitor, yep. Let's see. 200 nanofarads. By the way, these are usually found on the mains to smooth out any noise and things that may come through the mains power lines. Come on. This is 4.3 and it's marked at 4.7. For this one, I should probably increase to 1 kilohertz. 4.1 still, so yeah, apparently that's just its value. Second thing, you can actually manually choose what to measure. Resistance, capacitance, or diodes actually. Let's see how good it is for tweezers. Let me pull out an LED and see if it can measure it. I doubt it since the 4 voltage is pretty high. Yeah, no, it can't measure a resistor, but I found a diode. Let's see. What is this? A 1N404. So I believe this is like for a bridge rectifier Schottky diode, I think. And first of all, it can show you the direction, which is actually pretty nice. You can see what way you're supposed to, it's supposed to be marked. So, and come on. And the forward voltage, it's 0.51 volts. Nice. So, I believe these are marketed as SMD tweezers to measure in circuit, but I'm gonna be honest, they're pretty bulky for that. So, I mean, I guess we could give it a try while we're at it. And I actually don't have any quick inductors aside from this one to measure, so let's see, can it measure it? Wait, oh, it has a beeper. Nice. I don't know how useful that is on a LCR meter, but sure. Can it outrange? Yes. 4.5 microhenries. And this is 4R7. I believe that's right. 4 point, it's supposed to be 4.7, but it seems to be measuring pretty accurately. But this is a pretty big component. I believe they advertise measuring like these capacitors. Well, while they're mounted on a board, they can be measured actually pretty easily. At least the bigger ones. Yeah, I'm pretty sure if I try to measure this one, it's gonna be... No, man, can... But it cannot choose what kind of thing it is. I don't know, is that a diode? I'm pretty sure that's a diode. But if you had like capacitors in that you get from a spool, I am pretty sure measuring with this ain't gonna be that great because how big it is. But I guess for measuring in circuit, it's gonna do its job quite alright. Like 18.85 microfarads. I can't particularly tell you what this one is because they don't have any markings. But again, seems pretty right. Let's test if it can measure a diode on auto. Oh, is that a fuse? I think I just measured the fuse. Maybe. Uh, let's just try this one. This thing. What is it? It's a bridge. It's a 10 milliohm bridge. Alright, anyways, the point is that it works moderately well for what it is. And for like 30 bucks, you can get these from different brands. Mine is from Snackle or something. But you can get them from Zoe or Finorsi or I don't know, whatever. There's a lot of brands that do these kind of things. But it actually seems to be doing a pretty alright job. And it comes with a alright case. I have a feeling very soon I'm gonna go take a box cutter to it. But, you know, it comes with a USB, some replacement tips in case you someone break those massive tips measuring somehow. I'm gonna ask how it comes with a user manual, which, I mean, it's pretty self-explanatory, I guess. It's just and right. Let me show you the menu. You have language, direction to change back and forth, volume, backlight, and timers, how fast it turns off automatically, calibration, which I actually don't really know how to do. I should probably actually check the menu, but restore probably factory settings and about V 1.8. You hold down the button and that's how you turn it off. So yeah, this is just my video on cool tools to know about. Some of you may find them useful, some not, but just wanted to make this video. So bye.